A very good morning to one and all present here. Dear authors and invited guests, welcome to technical session 8G. Myself, Harsh Soni, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 4th World Conference on Information Systems for Business Management, ISBM 2025. The 4th edition of the conference is being organized in hybrid mode. The physical event was held on 24th of September in Bangkok, Thailand, and the virtual event is being held through Zoom yesterday and today, that means 25th and 26th of September 2025. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for the question. On 9 minutes, I will raise a gentle reminder so that you can conclude your presentation. There is another request to all the participants that you may all please stay connected with us till the closing remarks, because there is one publication update that we have to give you at the end. If you have any query or update, you can write it to me directly in the chat box. Just before we get started, I'd like to introduce you all to the chair for the session, Dr. Rina S. Satpute. Dr. Rina is as an assistant professor at the Tamege Institute of Higher Education and Research, India, an accomplished educator and researcher with over 17 years of academic and industry experience. She specializes in computer science and engineering with a focus on artificial intelligence, neural language processing, and programming in Java and Python. She has published 21 research papers in national and international journals, most of which are Scopus indexed. Welcome, ma'am.
Thank you, sir. Thank you very much.
Yes. We do have Dr. Kinjal Bhatia. Dr. Kinjal is an assistant professor at Charotar University of Science and Technology, India, with 8 years of dedicated experience in academia. She has authored and published 4 research papers, contributing significantly to her areas of expertise. Her specialization includes psychoanalytic criticism, translation studies, comparative literature, feminist and gender studies, and the evolution of the short story in world literature. Welcome, ma'am.
Thank you. Thank you so much.
Ma'am, do you have any opening remarks for our participants?
Is it ma'am who is initiating, or should I go for it?
Yes, you can go for it, ma'am.
Okay. So, good afternoon or good morning, all the scholars and participants. I welcome you all to this session of the 4th World Conference on Information Systems for Business Management. In our rapidly evolving era of this digital transformation and information governance, this interplay of technology, business management, and policy is more consequential than ever. So I appreciate that ISBM 2025 is conceived as a forum which deliberately go with key challenges and opportunities in this intersecting domains that we are having: system design, data governance, ESG, integration, information policy, and strategic decision making. So we are fortunate today to feature an excellent lineup of speakers whose research is intersecting between these themes. So I welcome all the participants to this session, and we are looking forward towards the fruitful discussion during this session. Thank you.
Thank you, ma'am. Reena, ma'am, do you have any opening remarks for the participants?
Yes, sir. First of all, I would like to welcome here, and it's my great privilege and honor to welcome you all on this technical session of 4th World Conference of Information System and Business Management, hosted in vibrant city of Bangkok, Thailand. And it's great pleasure for me to being part of this. Here, I would like to wish all the participants best luck, and please give your best. Let's have a global discussion here where we will add some values here, some innovative skills to make this conference with some positive output. Thank you very much.
Thank you, ma'am, for your kind remarks. Now I'd like to introduce first participants. We have Mary Ann, and they are presenting the paper adaptability of 5G, IoT, and AI Philippine digital infrastructure comparative insights from Asian and global leaders. Dear participants, are you there?
Yes, I am here. So can I share my screen?
Yes, you may please proceed with the presentation.
Okay, sure. Okay, is my screen visible?
Yes,
Yeah.
we can see it.
Okay, so hello everyone. Good day. I am Mary Ann, and with the guidance of my co-author, Dr. Jerry Henove, it's our pleasure to share with you our study on the adaptability of 5G, IoT, and AI in the Philippines digital infrastructure with comparative insights from ASEAN peers and global leaders. So my agenda for this presentation is to briefly introduce the background and motivation of this paper, the methodology used, and the key findings from the research questions, and finally concluding with a suggestion for the next steps. So globally, 5G, IoT, and AI are no longer just emerging concepts, but they are already transforming how the societies operate. And they are actually building on one another, with 5G being the backbone, providing fast and reliable connectivity, and IoT extending this by connecting billions of devices together, and AI transforming the resulting data into insights and automated actions. And together, these technologies are driving advances in areas such as the smart cities, digital healthcare, and intelligent transport. For the Philippines, it is actually facing a complex situation. Why? It's because for the Philippines, there are national ICT frameworks in place, yet the implementation of these technologies are slow and uneven. There is a digital divide, and particularly between the cities and the rural communities. Meanwhile, our ASEAN peers and global leaders are advancing faster. So this led us to our four guiding questions, like where is the Philippines now in terms of the adoption of this technology? What are the factors that are influencing its adaptability? How does it compare with other countries? And most importantly, what steps should be taken next? And to explore these questions, we have conducted a systematic literature review from drawing insights from academic studies, government documents, and industry reports. We also examined the Philippines landscape alongside four ASEAN peers and four global leaders, each offering different lessons, either through shared challenges or distinct strategies. So, for the first question is, where does the Philippines stand today in terms of the adoption? The short answer is adoption is advancing, but it is uneven. Why? First, 5G rollout is progressing in major cities. There are initiatives in smart cities, enterprise connectivity. Yet, rural penetration remains weak, and the spectrum allocation has been delayed. For IoT, it is also in an early stage of adoption, and it is expected to grow at 20% annually for areas like utilities, agriculture, and logistics. Though there are challenges in rural connectivity and standard frameworks, and also cybersecurity concerns remain. For AI adoption, it is mostly concentrated on pilot projects in enterprises and telecoms, like the use of chatbots or any detection application. But there is also limited governance on AI frameworks, and there are less technical experts for national implementation. So overall, the landscape shows some promise, but most of the initiative remain in pilot stages. And this brings us to the question why scaling has been difficult for the Philippines. And the barriers fall into three main categories. On the socio-economic side, there's high broadband cost, there is income inequality, and there is regional differences, keeping many of the communities excluded from digital access, even though the demand for digital services is rising. For the regulatory side, there is bureaucratic inefficiencies and fragmented governance, delaying the spectrum allocation, which creates inconsistent enforcement of implementation across the regions. And finally, for infrastructure challenges, it is stemming from the Philippines being an archipelago and its exposure to natural disasters like typhoons. Both of these challenges raises the cost and increases the vulnerability of implementation. While these barriers help us understand why adoption has moved forward in some areas, but it remains fragile and uneven overall. And to put these challenges into perspective, we compared the Philippines with 8 countries. We grouped them into comparable contexts and distinct contexts. This will help us identify like which barriers are unique and which have already been successfully addressed by other countries. So, for comparable context, we see that Japan, being also an archipelago, has integrated the digital inclusion into their national strategies under the Society 5.0. This shows that the geography may not be or need not to be a permanent barrier. Vietnam, being a country that has comparable economic standing with the Philippines, also have accelerated their adoption by embedding industrial IoT into its strong point, which is the manufacturing sector. For Malaysia, they have implemented centralized spectrum management that avoided duplication and reduced delays. And Thailand has also implemented regulatory sandboxes that create controlled environments for experimentations. So from these examples, it suggests that the Philippines barrier, like the geography, the affordability, and the governance, can actually be addressed if they have a coherent strategy. And for countries with distinct contexts, we see that, for example, Singapore, being the Southeast Asian nation global leading leader, it illustrated the importance of having clear policies and nationwide rollouts. For South Korea, it shows how the public-private partnerships can rapidly scale the adoption, having been the first to launch the nationwide 5G. For United States, it highlighted the flexible spectrum management and market-driven innovation, and Germany demonstrating the industrial IoT and AI being can strengthen the competitiveness when it is tied to economic policies. So from both of these tables, the lessons that we take from this analysis emphasizes that the importance of the vision, the governance, and the strategic alignment with broader development goals. So from these lessons, the next question would be, what should we do next? Or what is the next steps for the Philippines? So we have proposed 3 clusters of strategies for the Philippines. The strategic measure of the Philippines should begin with the infrastructure and inclusion, expanding the rural broadband, shared backbone networks, and targeted subsidies to close the digital divide. And with this foundation, the policy reforms through predictable spectrum auctions and sandboxes can also foster innovation, while the nationwide skills program and stronger monitoring ICT initiative should be also in place to sustain long-term progress. So together, these strategies can is forming a roadmap for moving beyond the pilot stage and towards a nationwide integration. And to conclude my presentation, the Philippines is in the early but uneven stages of the 5G IoT and AI adoption. Progress is still concentrated in urban areas and enterprises, while rural communities and smaller industries remain at margin. The barriers of inequality, governance, and geography remain significant, yet from the comparative insights, this shows that they can be overcome with the right strategies. But ultimately, the success will depend on embedding this digital adoption into a wider socio-economic and industrial policy to ensure that it is inclusive and it is sustainable. So this study draws from secondary sources and will require further research for validation, but the strategies identified here provide a starting point for guiding digital adaptation in the Philippines. And like our ASEAN peers and global leaders, the Philippines can also overcome its barriers, but only if we have strategy, governance, and inclusion moving together. So yeah, this concludes my presentation today. Thank you.
Thank you, dear presenter. Ma'am, do we have any question for the presenter?
Can I initiate?
Yes, ma'am.
Okay. So sorry, ma'am, to interrupt you.
No, it's okay.
Your findings have highlighted this coherence and digital upskilling, but what is one actionable intervention or policy intervention in a short term that you can introduce or that can uplift the digital upskilling that you have already shared?
Yes, ma'am. Thank you for okay. So actually, for the Philippines, they have already a policy in place, a framework. They have the National Broadband Plan and they have the National ICT Framework. Although the plans are in place, but the policy is in place, but the implementation and enforcement is not consistent throughout the region. So the first thing that we can do is um, to enforce this properly. So there should be someone monitoring the initiatives they have already have in place before we introduce something new for them. Yeah, thank you.
Good, thank you.
Miss Mary, your presentation was wonderful. Here I would like to ask one question. In your opinion, which sector will benefit the most out of this adaptability?
Thank you, ma'am, for the question. So, in my opinion, I think the the sector that will benefit most will be for the disaster risk management. So, if we have this AI, IoT, and 5G together in place, it can actually help the country be able to work ahead. Like being the Philippines being in the Pacific region, it's always prone to typhoons, prone to earthquakes. So with these technologies working together, it can help the government to be able to actually put in place some solutions before it happens, because there is early detections, there is early warnings for us to be able to plan ahead. Yeah, thank you.
Okay, thank you, sir. And wonderful answer, Miss Mary. Wonderful explanation, and you are having good command on your research. So,
Thank
Thank
so
you,
shall we
ma'am.
go with next? Yeah.
Yes, ma'am. Okay, so next we have Monica, and she's going to present the paper on Beyond Engineering to Order, Embracing Legal in Smart Manufacturing Planning for Boost Sustainability.
Hello everyone.
Hello,
A
ma'am.
moment to present the document, please.
Ma'am, am I audible?
Yes, yes, sir.
Okay. Is Vayu available there?
Sir, echo is
I-
going on. Please check. I guess
Okay,
two
now it
devices are
is there.
connected simultaneously.
uh,
Yeah, it's fine.
Okay. Vayu, may I please present your paper? I think so. She's also not here in this meeting.
okay.
Next we have Jaimin Dave for presenting the paper title Enhancing Intrusion Detection with Hybrid Deep Learning and Tree-Based Models with XGBoost and Light GBM. His presenter is available in this meeting? Hello? Is Jaimin is available in this meeting? Okay, am I audible to everyone or not?
Yes, you are very much audible.
Audible, sir.
Okay, so I think the presenter is not responding in this meeting. Okay, then move forward for the next presenter, Lucas. Is Lucas available?
Yes, I'm here.
Yes,
I
Lucas.
already started the microphone when I saw the
Okay.
queue.
Okay, yeah, thank you for responding. You may
Yeah,
please
but it's
present your paper title Implementing Zero Trust Architecture in SMEs, Readiness,
okay.
Barriers, and Tailored Support Strategies, Evidence from the Czech Republic.
Okay, just give me a second. I will start screening, share screening. If you can please confirm if you can see my presentation.
Yeah, yes, we can say it.
Okay, great. Okay, so good morning, ladies and gentlemen. My name is Lucas Herod, and I will present a study which I conducted together with my colleague from India, Arvind Panwar. And our research is focused on implementing zero trust architecture in small and medium-sized enterprises within Czech Republic, in particular on readiness, barriers, and the kinds of supports this type of companies like small and medium enterprises, what they actually need. From the motivation, CMEs from the backbone are the backbone of the Czech Republic and European economy, but they are also among the most vulnerable targets when it comes to cybersecurity nowadays. Many of them operate with a limited budget, limited IT staff, and often without some dedicated security specialists. At the same time, regulatory requirements are increasing. Now in European, we have a new regulation, NIS2 directive, and the DORA regulation, which place higher demands even on smaller companies that never considered themselves as a critical infrastructure before. This creates a paradox. On one side, SMEs face the same threats as the large enterprises, but on the other side, they lack the resources and expertise to respond. Zero trust architecture has been promoted as a modern security paradigm that could provide some resilience, but we didn't know how realistic is for this type of small and medium companies. So our motivation was therefore to explore if SMEs even know about zero trust and how far had they already gone in implementing related measures and what prevent them from moving further. Research objectives. Based on this motivation, our study had three main objectives. First, to measure awareness and readiness of SMEs towards to zero trust architecture. Awareness is crucial because if you don't know the concept, you cannot actively implement it. The second, we wanted to identify barriers and support needs. What exactly is holding SMEs back? It's a money, knowledge, technology, or regulation, and what forms of support would make the difference. Third, we wanted to translate these findings into some practical roadmap. The idea was not only to produce numbers, but also to give some policymakers, associations, and SMEs themselves some concrete guidance on where to start, how to progress step by step, and what help to ask for. These three objectives structure the whole study and actually my presentation today. We have 4 research questions. You can see them. You can see them on a screen. The first question asks about awareness. Do SMEs actually know what zero trust architecture is? The second focus on some governance factors. Does having a formal security policy or providing regular training increase readiness inside this type of companies? The third question look at barriers. What exactly prevents SMEs from adopting zero trust architecture? And fourth question explores differences by firm size, because the micro companies, when they have 2-3 employees, are a little bit different than small and medium enterprises in this type of context. And these 4 questions gave us a structure, a way to examine not only the current state of adoption, but also the underlying factors to shape it. You can see that we have 5 hypotheses. The first one was predicted that fewer than half of this type of companies would be aware of zero trust architecture. 2 and 3 predicted that security policy and training would increase readiness. 4 hypotheses stated that cost and lack of expertise are the main reason for low adoption. And the 5th hypothesis expected that the larger companies, larger SMEs would have implemented more elements of the zero trust architecture than the smaller one. We conducted an online survey among Czech companies, among Czech SMEs. In total, we collected 230 valid responses. All respondents answered the basic question covering company profile, IT department, some information about. And out of these, 118 respondents who indicate that they were at least somehow familiar with this type of this zero trust architecture. We asked them for some specific and more detailed tasks. We classify this type of firms regarding to regulation, to micro, small, and medium, based on the official definition of European Union. And this classification was quite important for us because we thought, and in the results you can see, that the firm size influenced not only resources, but also the mindset towards to security. And let's take a look for some results. I will start with awareness. When we ask about zero trust architecture, only about 1/4 of respondents said they understand it in detail. Another group had heard the term, but without some deeper knowledge. Although the majority of SMEs could not clearly describe what zero trust architecture actually means. This confirms our first hypothesis that less than half of SMEs are aware of the concept. For us, this is an important finding because it shows that many smaller companies are already being asked to comply with requirements, but they don't know how to fulfill them in not only correct way, but systematically and with some knowledge. In practice, it means the awareness campaign and training may be necessary before we can even talk about structure implementation. Otherwise, zero trust architecture risk remaining something like a buzzword with a little impact on actual security in a small firm. The readiness factor, it was our as a second research question, how or which governance factors influence readiness of zero trust architecture. We tested two, in particular, the presence of a formal security policy and the frequency of employee training. The results were striking. Firm with a written and enforced security policy has significantly higher readiness score. Their median was 4.56, as you can see on a screen, compared to not almost 3 in firm without such a policy. Similarly, trained played a role. Companies that train their staff at least once per year reach a median readiness of 4.19, while those training less frequently or without the systematically training had only 3.25. This clearly confirms our hypothesis 2 and 3. It shows that the governance is not just bureaucracy, it translates into real capacity to adopt technical measures. In other words, SMEs that invest in policies and training build the foundation for zero trust, even if they have limited budgets for advanced tools. This is a powerful message for both managers and policymakers that improving governance is a relatively low-cost enabler that can accelerate readiness and help to actually to everybody. The third question addressed barriers. Here we ask SMEs to rate which obstacles prevent them from implementing ZTA principles. 3 barriers dominate the answers. First, lack of expertise. 70% of respondents said they simply do not have the knowledge or staff capacity to design and operate something like a zero trust environment. This reflects the structural problems of SMEs. They often have one IT generalist, one IT specialist, but not a dedicated person for a security or even security team. Second, high cost, 67% cited financial limitations. For many SMEs, even license for advanced tools or cloud solution are beyond reach. Third, complexity, 52% found ZTA, zero trust architecture, too complicated to understand or integrate into the existing system. It's based on their size, of course. Together, these barriers confirm also our hypothesis number 4, also on a statistical level. And this is the last results, if I'm right, or maybe one more. To understand how to overcome these barriers, we ask SMEs what support they would actually welcome. Here is the results. We are not uniformly different by firm size. Smaller firms, meaning micro and small enterprises, emphasized financial support and training. This makes sense. They operate with tight budgets and like in-house expertise, as I already said. So they need both money and knowledge. And medium-sized firms or companies, on the other hand, pointed more often to expert consultation. It's the next level after training, and to practical scenarios, which can show them easily how zero trust architecture can be implemented in practice. These companies already have some IT capacity, but they need guidance and tailored advice to apply zero trust in their specific context. This finding is crucial for policy design. One size fits all support will not work in this example. Founding and training programs are effective for smaller firms, with larger SMEs require consulting and practical roadmaps. That's what we need to think about. And next, we tested whether there are actually difference in the number of ZTA elements implementing by firm size. As you can see on a slide, micro firms had on average 2.65 elements implemented. Small firms had higher, 4.2. Medium had 5 elements implemented. This confirms hypothesis 5. Larger SMEs are further ahead in ZTA adoption. The implication is straightforward. Capacity grows with size. Micro firms are barely starting, while medium firms are already halfway through. This suggests that any roadmap must be phased. Expecting micro firms to jump straight into full ZTA would be unrealistic for them. Instead, we need gradually step the scale with the firm size. And here is also, we made some tests about the security categories, but I think the most, well, just we put together some parts of ZTA in a groups and tested separately, but I think this is not the key for us, and I will move to discussion and to the end of my presentation. Taken together, the results provide three key insights. First, implementation is selective. SMEs adopt individual controls that are easy to understand and justify, but rarely embrace the full zero trust framework. This selectiveness reflects both limited awareness and paradigmatic approach. They secure what they know and can afford. The second, governance acts is an enabler. Security policies and training may look intangible, but they are the backbone that makes technical adoption possible. Without them, readiness remains low, no matter how many tools a firm can afford. Third barriers are multifaceted. They are not only technical, such as lack of tools or expertise, but also organizational and financial. This reminds us that zero trust cannot be achieved by technology alone. It requires organizational change, managerial commitment, and some external incentives. So I also mentioned a roadmap. So we try to create a roadmap, which actually basically some 3 phases, and you can take a look detailedly in our paper. If I will move to summary of results, awareness is low. Only about a quarter of SMEs understand DTA in details. Readiness is strongly influenced by governance. Having a policy and regular training makes a measurable difference. The main barriers are lack of expertise, cost, and perceived complexity, and firm size matter. Medium firms are ahead of micro firms and training. And finally, SME requires support in the form of roadmaps, training, and financial incentives with different priorities depending on a size. You can see we also mention a limitation, which is regarding to Czech Republic limitation, the size of a number of companies, etc., etc., etc. So, in conclusion, awareness of zero trust architecture among SMEs is still very low. However, many firms has already implemented individual elements, even if they do not label them as a ZTA. And I think this is the most important message, that we need to focus a little bit more for this type of smaller company and try to find some maybe way how we can help them with the integration of a security. And that's everything from my side. Thank you for your attention. I hope I was not so long.
Yeah, thank you, Lucas, for your presentation. Rina ma'am, do you have any question for the presenter?
Yes, Lucas, I would like to know what unique challenges do small and medium enterprises face compared to large enterprise in adopting zero trust?
Yeah, we have this on the slide, where is just the barriers from the point of micro and small medium firms, these 2 categories, but from point of large companies, more than 250 employees, that's a little bit different because the large companies have a lot of money. They know that this is crucial for them, and even they have a lot of time to adopt for a new environment, also for regulation, because they are, especially in Europe, under this called critical infrastructure more than 4 years. So they have a lot of money, they have a knowledge, and they are really in advance. But now the medium needs not the money, they also have a money, but they don't know how to do it in a correct way. And small and micro farms, they need money and show them from the very basic what zero trust architecture is and how it can help, like two-factor authorization. This is a main concept from the zero trust architecture. I think everybody is using our smartphones to confirm that this is your identity. That's a zero trust.
Another question here I would like to ask, how transferable are your findings from the Czech Republic to SMEs in other regions?
Yes, they are quite easily usable in the whole European Union because we all need to follow the same regulation and same rules. So what is in this study should be applied for the whole European Union. Outside of European Union, it's a little bit different. For example, the zero trust architecture comes from a United States regulation, so we can also do the same over there. But in a countries from my point on a east, I mean Thailand, India, it's an absolutely different situation, and that's the reason why I have Indian co-authors on my paper, and we try to now make it a little bit wider study on this and try to focus more not only on European Union, but also to other countries, because I think we can find something which is similar, but also some huge differences. And it will be really, really interesting to compare the both approaches, which are quite challenging for us.
Yeah, that will be really the great favor. Because governments are now more focusing on this small and medium scale enterprises. So your study and your findings will greatly help. Thank you
Okay,
very
thank you.
much.
Thank you very much.
Rina ma'am, do you have any question for the present?
Yes, I just want to ask one thing, that how can your composite readiness index that you have, that can be applied by this policymakers to prioritize these interventions that you have mentioned?
Okay, I will unmute. Okay, we find some problems, some barriers, and next step, maybe locally in Czech Republic or European Union, is to come to our government policies and try to explain them that it's not so easy how it's in this regulation written. They need to follow it, but they don't know how, and they don't have the money. But I think they don't want to listen it. They are more focused on themselves, and for them, I don't know if it's useful for them to extend this regulation also for this type of companies. They know that there are lots of cyber attacks also for medium and small companies, but it's it's quite challenging. I think they are a little bit like behind. Nobody takes care about them. So we have a new regulation. You need to follow the regulation. It's your problem. Yeah, that's especially in European Union.
Okay, so any other low barrier cybersecurity, I'll say, solutions you have in your studies that you can provide that for smaller enterprises, especially?
Yes, we have something like this. We are now trying to talk also with some small regional non-government agencies in Czech Republic to prepare at least some training, some consulting programs. We can use European fundings for this, but it's the same. It needs to start from bottom, not from the top, because from the top they are just focusing on the high and large enterprises.
That's great. I'll say now you can explore your limitations to another research paper, and hope to see you growing the same way. Thank you.
Okay, thank you very much.
Thank you.
Thank you, Lucas, and thank you, ma'am, for your questions. Now, without wasting time, I'd like to invite the first presenter who led the presentation in between the session. Monica, are you ready for with the presentation?
Yeah. Hello. I come back. Sorry, I had some connection problem.
Yes. Meanwhile, you are sharing the presentation. I request all the participants that you may all please stay connect, be ready with your presentation and please follow the timeline.
Well, okay. Good afternoon or good evening, everyone. We are pleased to present our research title Beyond Learning in Embracing Learning in Smart Manufacturing Planning for Boosting Sustainability. Well, introduction. Our study addressed the challenge faced in manufacturing systems that are based on engineering to order. We argued that implement Industry 4.0 technologies together with agile planning can increase efficiency, flexibility, and sustainability. To support this paper, we use a decision-making approach based on fuzzy analytic hardware process or FHP. Literature review. From the literature, we found three key areas. First, engineering to order strategy, operation, and results. On second, the agile approach merge lean efficiency with agile flexibility, which is essential for dynamic production. And third is digital tools such as digital value stream mapping, machine learning, and additive manufacturing, support transparency, waste reduction, and faster response to customer needs. Well, in addition, smart manufacturing planning and sustainability are essential. For example, reinforcement learning and real-time data allow flexible schedule. Additive manufacturing reduce waste and lead times, while Industry 5.0 highlights your resilience and human-centered design. These insights confirm that sustainability is not a trade-off, but can go hand in hand with competitiveness. Okay, and identification of drivers. Based on the literature, we identify a set of strategy drivers. These drivers integrate EA2, agile, smart manufacturing, and sustainability practices, and they form the foundation of our analysis. And methodology to prioritize these drivers, we applied the FAHP. This method structures the decision problem into levels, goals, criteria, and subcriteria. Expert provides a judgment through fuzzy pairwise comparison, and the process generates related predicting weights. And the steps on the methodology and identification of model variables. In the initial phase, the principal strategy drivers were systematically identified through an extensive review of relevant literature and see table 1. The selected strategy include ETO, agile, smart manufacturing planning, and sustainability. For consistency and ease of reference within the model, each driver was assigned a code. And the second, computation of Chris weights. A fuzzy pairwise comparison matrix was constructed for expert input and aggregate across responses, after which the values were diffused into price weights. And the third normalized of the weights. The crease weights were normalized and they multiplied by their dimension scores to obtain the global weights, which determine the final ranking. And finally, classification and ranking of driver. In the final stage, driver weights were ranked in descending order to establish prioritization. And case study is the result shows that the most important drivers are digital integration, digital value stream, and integrated planning. Together, they represent the backbone of sustainability and adaptive supply chains. And this means that digitalization is more effective when combined with synchronization planning and integration. The integration of EETO, Agile, Smart Manufacturing Planning, and Sustainability strategies provide a structured framework for assessing supply chain in dynamic environments where the FHP identify the most critical driver for flexibility, efficiency, and long-term competitiveness. And for the weighting of each criterion, experts with more than 10 years of experience were selected, which determined the value of each code, while potential bias was mitigated by consistency checks and aggregation of judgments. And conclusion and future research. In conclusion, our research confirms that combined customization, digitalization, agility, and sustainability increase competitiveness and resilience. We also highlight that ecological practices like waste reduction and supply collaboration are increasingly aligned with business advantages. For future research, we recommend apply our framework to other industries and integrated advanced technology such as AI, IoT, and digital twins. And thank you for your attention.
Thank you, Monica. Rima ma'am, do you have any question for the president?
Yes, yes. Miss Monica, I would like to know what is your views about boosting sustainability? Boosting sustainability, particularly in a smart manufacturing field.
Well, one of the main challenges is the limited adoption of advanced technology due to the investment costs and infrastructure gaps. However, Peru also has opportunity growing awareness of sustainability, government support for innovation and industry, such as mining and agriculture, that can greatly benefit for digitization. And in Peru, many companies, especially in construction, mining, and manufacturing, work with engineering to order projects where customer requirements are very specific. And the challenge is to reduce long lead times, and that exactly where digitalization and agile planning can provide significant improvements.
Okay. Can you please elaborate what this legal approach does means?
Excuse me? Can I repeat, please?
Embracing legal in smart manufacturing planning for a boost sustainability. So my question is, Can you please elaborate more on the legal approach in terms of smart manufacturing?
Well,
Did you get my question?
yes. We believe sustainability will increasingly integrate a business advantage with Industry 5.0, resilience and sustainability. Another is
Okay. Angel ma'am, do you have any question for Monica?
Yes, just one question, Monica, for you. That among this digital integration, digital value stream, and integrated planning, you have mentioned three in your case study. So, out of these three, what do you think? Which one is the most critical driver in your case study, and why it is so? Hope you get the question.
Ma'am, I think so. Monica left the meeting.
No worries, no worries. Thank you.
Okay. Okay. So moving for the next presenter. Just my screen is working right now. So just a second.
Hello. Hello.
Hello.
Am I audible? This is Sharda here.
Yes, ma'am.
Yeah, I request you to please permit me to present next. I have a class at 12:35 Indian Standard Time. So I wish to finish it so that I can entertain the question answers also. And then I need to go to the class. If it is possible, then please arrange for my presentation now.
If sessions are allowed, then ma'am.
Yes, definitely.
Yes, yes. Yeah, no problem, sir.
Okay, Shada ma'am, you can present your paper titled Securing System Through Log Anomaly Detection from Traditional Learning to LLM.
Yeah, thank you so much. I hope I am clearly audible to you all.
Yes.
Yes.
Yeah, okay. So I'm sharing the screen then. I hope it's visible, right?
Yes, ma'am.
Yeah. Okay. So I'm here to present today the paper titled Securing Systems Through Log Anomaly Detection, wherein we navigate from the traditional learning methodologies to the large language models, which we call as LLMs in short. This is the agenda of presentation today. So we know that anomaly detection is very important in cybersecurity as a specialization. It is a major in cybersecurity. So the log anomaly detection is once again very important because with the advent of various tools to use for the user, with the advent of AI-based technologies in place, and also with the change in the digital pace of technology, the logs have become infinite. So the logs are continuously and ever increasing. So from the logs, we are required to identify if there is any anomaly and take corrective action before it hampers the performance of the entire system. So the final target is to make the system resilient by handling the anomalies with the help of the log analysis. So for that, we have done a study, a meticulous study in which we understand, first of all, about what are the various approaches which have been used in the past and what are the upcoming features which must be used. So log is very important to analyze the log because it helps in maintaining the health and security of the system. We intend to prevent the failures, which can be a catastrophe if the logs are not analyzed and appropriate mitigation strategies are not followed. So manual analysis of this ever-increasing log is not possible, and hence it is required to make use of AI, ML, and other deep learning and transformer as well as LLMs to process this log, because log speaks about the patterns and log is ever increasing and dynamic, as I just told. So the key challenges associated with this involve huge data, diversified applications, and ever evolving logs. Also, there is a challenge with the detection. It means at times, due to the advent of various softwares, the kind of upgrades that happen, it is difficult to catch a semantic or a pattern among these anomalies as well. So that is another challenge. And the third one is the parsing issue. The parsing issues indicate the errors which can remain present at the time of identifying the patterns from the given log. So it is more or less like you are having a log available with you. The log can be from a mobile phone or from a web server or a desktop or even from the firewall, and you are trying to establish a pattern whereby you can identify the anomalies. Let me define an anomaly for you. Anomaly is any kind of behavior which is not normal for the system, and hence anomaly can be attack, anomaly may not be an attack. So every anomaly which is detected also need not be an attack. So that is what I need to make clear from this point. So there have been several approaches which researchers have been using. Researchers have been employing the statistical as well as the finite state machine-based approach. Now, because of the ever-evolving size of the log, the traditional approaches will not function, and hence researchers since years have started working on the machine learning based approaches. So when we speak of the traditional machine learning based approaches, you can categorize them into supervised, semi-supervised, and also unsupervised learning. So as far as the supervised or semi-supervised are concerned, the supervised, they play a very important role in anomaly detection, and they leverage labeled data in several ways to identify outliers or abnormal patterns. So support vector machines, decision trees, then these are all considered under the supervised approaches. The unsupervised approaches or rather semi-supervised anomaly detection is designed for contexts where labeled anomalies are scarce, but some labeled data is available alongside a large pool of unlabeled data. So the model here is trained to understand normal behavior first using the labeled normal data. And when the trained model is exposed to unlabeled samples, then how far it is deviating from the normality is detected and flagged as anomaly. So there are several terms which are important over here, like flagging something as normal, a threshold setting to detect anomaly, then labeled data, unlabeled data. When we are taking data directly from the PC, it is generally unlabeled. So first of all, pre-processing is required to be done, and so on and so forth. So it has its own set of challenges. So the drain parser, when combined with the deep log for anomaly detection, enables structured transformation of raw data logs into fixed templates. So deep log then models as sequence for accurate anomaly detection. So this integration improves anomaly detection, anomaly identification by effectively extracting events from logs and learning normal versus abnormal patterns. Then after we have topic modeling and ensembles. So when XGBoost is combined with short text modeling, it provides superior classification and topic coherence for brief texts. And it works better in comparison to the latent Dirichlet allocation, which we call as LDA for short. So this approach enhances both accuracy and semantic relevance. Then we have several deep learning approaches also, in which the first approach is the LSTM-based models. LSTM models like ADA and DeepCP are highly effective for anomaly detection. They capture temporal dependencies in sequential data and handle multiple variables simultaneously. The memory cells available in these models enable accurate detection of anomalies in complex time series patterns. And then we have the second type, which is the attention models. The attention models like BiLSTM and CNN by GRU capture rich semantic features by focusing on important parts of the sequences and multidimensional inputs. So they enhance anomaly detection accuracy. So the attention mechanisms enable these models to effectively distinguish normal and abnormal patterns. They weigh relevant contextual information also with the required data sequences for pattern recognition and pattern creation, detection, and recognition. The CNN models are highly effective for feature extraction. They have an accuracy of up to 99% as shown here. They detect anomalies by automatically learning event relationships with the log data. So these models use convolutional layers to capture local patterns and hierarchical features from logs, thereby enabling precise identification of normal versus anomalous behavior in complex system logs. Then the last models which we have are hybrid models. So hybrid models are available like as mentioned here, TCN, log2 vector and lognet. They
Sorry to
combine.
interrupt you, ma'am, but this is a last 2-minute reminder.
Okay, so they combine multiple techniques such as temporal convolutional neural networks, graph-based log feature extraction, and neural encoders, autoencoders to leverage both sequential patterns and log content. So then after we have the transformer-based approaches also, like BERT models have been identified. They learn semantics and they also support few short learnings. Then we have sentiment-based log analysis also. So it detects anomalies by sentiment shifts in logs. Then we have lightweight BERT, which includes multi-log as well. So this is a smaller model and it offers a better competitive performance in comparison to others. Then we have the LLM-based approaches. So the first one is the chat GLM that we have. Then we have enriched logs. We have RAG techniques. I'm very much impressed with the RAG technique because the RAG techniques, as exemplified by log-RAG, improve anomaly detection by combining log template information with content analysis at runtime. So it combines the template analysis and also the content at runtime and hence it improves the F1 score as well. LLM-based parsing generates regular expressions using semantic understanding capabilities of large language models, and it achieves around 96% accuracy. So when we compare, these are all benchmark data sets, and we can see that the data set is available from which source. So what is the size of the data set? How much is the anomaly ratio? These are some of the benchmark data sets which have been processed for these LLM-based log analysis. The comparative study is also mentioned over here. We can see that the LLM-based approach outperforms the other approaches as such. Then there are several emerging trends also which are important to understand. The first one is the multimodal analysis. So multimodal analysis needs a combination of logs, variables, and the semantics. Then we have few or zero shot learnings. So here in this case, because it is a few or zero shot learning, such LLMs perform well with very less data as well. Now, if data is huge, you require higher processing. At the same time, you require the most of the time as a resource. While here in this case, it can do it quite efficiently. Then you have explainable AI. So here gradients are integrated for model transparency. Lightweight models are available, which are 50 times smaller, but better and efficient. Then we have semantic focus, where models are now able to understand the content, log content in a better way. So finally, we conclude that the field of anomaly detection is shifting from traditional machine learning techniques to LLM-enhanced methods. which leverage the contextual and semantic understanding capabilities. So models such as LLM, E-log, and LogRag are setting new performance benchmarks by combining semantic comprehension with log parsing and anomaly detection. So looking forward, emphasis is on real-time detection to quickly identify anomalies as they occur. Also, the enhanced model interpretability to explain AI decisions transparently is required. Okay, so these advances ensure anomaly detection systems and it can keep a pace with the rapidly changing hardware, the upgradations available in the software, introduction to new softwares in the systems, and also maintaining trust and actionable mitigation in the runtime. So this is what I had to present as a part of this particular study. So we have with us our student also, Prasham Shah, who was with us for the study work. He is also doing some implementation in this direction. And my other colleagues as well, Dr. Pimal Khanpara and Dr. Gaurang Raval. So in case you have any query, you can ask now. Hello?
Yes, ma'am.
Yes.
Yes. I would like to ask one question. What are the
Yes.
key challenges in applying LLM for cybersecurity log analysis?
Yes. So when we speak about the cybersecurity log analysis, the LLM-based approaches also have several issues, like there is a high computational cost because running large language models for parsing requires substantial processing power and memory, making it costly and impractical for real-time or large-scale deployments. Then the next one is the latency. Latency, it can introduce latency and it may not be suitable for scenarios requiring low latency log processing. Then we have dependence on pre-trained models. That is the third challenge. The fourth challenge is the training data, anomaly-based systems when we are developing. The data which we need to take for training purpose should be clean. So assuming you have an ideal data itself poses a challenge. You need to present the data to the model such that it is error-free, anomaly-free. So that is the next challenge. Then we have interpretability challenges as well. So this challenge comes when new softwares are introduced, new device drivers are introduced, and so on. Then rapid log evolution, which takes place due to all of these. Handling such a log is also a challenge. So these all challenges present trade-offs between the accuracy, flexibility, and efficiency for the LLMs-based log parsing solutions as well. Thank you.
Okay. Yeah. Thank you, ma'am.
Yeah.
Okay, ma'am, in context of what Reena ma'am has asked, I want to just ask that what are the future research directions you can see as the most critical for making this anomaly detection, which is more scalable and intelligent, as you are working with young professionals, I'll say your students. So what are the
Yes.
future direction that can be given to them so that we can make them more, I'll say, scalable and more intelligent to the system?
Yes, so there are two or three things. Firstly, I would not say it is an intelligent thing, but I want, if we are talking with reference to the students, I want the younger generation who are interested in working in the cybersecurity domain to focus more on the hardware security also. Now that for software security, what has happened is, I'm not talking about anomaly in general. When we speak about any kind of software security, we have got tools which can run over them and analyze. Now, as far as these LLMs and all are concerned, you need to have workstations which are dedicatedly doing this task if it is a critical zone. So first thing required is to identify a task, whether it is critical or it is a civilian task. So that identification of these tasks is very important. Secondly, regarding the data, where the data is stored, how it is being handled, and when whether the data is available openly to anyone or it is available in some other encrypted format or not. That is the second challenge. So the challenge starts from the designing of the system itself. And the third and the most important challenge is, as and when the logs are being processed, How are the mitigation strategies implemented? So the third most important thing is about the mitigation. Mitigation means you have to detect it, and before it actually starts impacting the system or the network, we are required to stop all those activities. So there is a technique which is based on the attack graphs, using which you can detect and you can prevent a particular attack. But the issue here is that it is not able to treat anomaly detection actually. So you need to identify the root cause at the runtime. So this is a huge challenge, and students should actually work on this also.
Okay. Thank you, ma'am. Thank you.
Thank you. Thank you. Should I stop sharing the screen?
Yes, ma'am.
Thank you.
Okay. So now next we have Vayu Vastuti for presenting the paper title Constitutionalizing Islamic Social Enterprise and Islamic Social Entrepreneurship Insights from a Systematic Literature Review.
Okay, I'm here right now. I'm trying to share my screen. Okay, so my voice are audible and also my screen has been shown. Okay, I will begin. So, good afternoon, ladies and gentlemen. Thank you so much for the opportunity. Today, I'm going to present about my paper. The title is Conceptualizing Islamic Social Enterprise and Islamic Social Entrepreneurship Insight from a Systematic Literature Review. So, this is, we will talk about the Islamic social enterprise and also Islamic social entrepreneurship. This research explores how Islamic principles are integrated into social business models and how these models contribute to both economic sustainability and also the social welfare. My presentation will cover the key definitions, thematic domains, findings, and also the practical applications with a special focus on the relevance for Muslim communities worldwide. So, this study is based on systematic literature review of 30 Scopus Index articles published between 2016 and 2025. These were carefully selected using rigorous inclusion criteria to ensure academic credibility. The aim was to analyze conceptual foundation, thematic trends, and the distinctions between Islamic social enterprise and also the Islamic social entrepreneurship. So we will talk one by one. So for the first, from the Islamic social enterprise. Islamic social enterprise refers to the organization that combine commercial and social objectives within an Islamic framework. Unlike the conventional businesses, these enterprises go beyond profit. They invest resources for poverty alleviation, community development, and also the social welfare. So there are the three main characteristic or the three main features from Islamic social enterprise. First, institutional framework. Second, community focus, and the last is reinvestment model. From the institutional framework, they are formally structured, governed by accountability standard, and must comply with Sharia principles. And the second, for the community focus, they often take the form of Islamic cooperatives such as wakaf-based businesses or zakat-driven enterprises serving underprivileged groups. And the last, reinvestment model, instead of distributing profits traditionally, surplus income is reinvested to further community welfare. So, we now go to the Islamic social entrepreneurship. By the contrast, Islamic social entrepreneurship emphasizes the individual entrepreneur as a change agent. Entrepreneurs mobilize resources to address social economic challenges while adhering to Islamic principles. Here, the focus is on personal qualities such as risk-taking, opportunity recognition, and also the innovation from the individual itself. Importantly, many young Muslim entrepreneurs are now leveraging technology and also the digital platform to build ventures with strong social impact. This show how dynamic and forward-looking Islamic social entrepreneurship has become. So this is the graphic that show us the publication trends and also the growth of the publication about Islamic social enterprise and also Islamic social entrepreneurship. We can see that the research interest in this field has grown significantly. From just one publication in 2016, the number rose steadily to 7 publications in 2025. This trend highlights increasing recognition of Islamic perspectives in social business, particularly after 2020, reflecting global shift toward ethical and faith-based approaches in entrepreneurship. So like I mentioned before, here I also give the literature reviews for major thematic domains, shaping both Islamic social enterprise and also the Islamic social entrepreneurship. First, governance. Second, innovation. The third is sustainability. And the last is Makoshit al-Sharia. From the governance, emphasize on accountability, transparency, and stakeholder trust through Islamic work ethics and Sharia compliance structures. When we talk about the innovation, it's about including digitalization, creative financing, halal certified practices, and entrepreneur intention as drivers of value creation. And from the sustainability, we see the balancing economic viability with ethical and social commitment, going beyond profit to include spiritual dimensions. And the last is about the Maqasid al-Sharia, serving as a guiding framework to protect faith, life, intellect, and world in decision making. So together for the major thematic here, these domains reflect how Islamic ethics deeply shape both institutional and entrepreneur practices. So after that, this is the leading academic journal. So from the 30 article that include in the systematic review, 6 from the Journal of Islamic Marketing, the another 6 from the Journal of Islamic Accounting and Business Research, and the 3 from Social Enterprise Journal, and the last 3 from the International Journal of Islamic Finance, and the rest is from another journals. So this is the key research finding from the systematic literature review. First, about the conceptual clarity, the second, about the complementary relationship, and the last for the mutual reinforcement. For the conceptual clarity, Islamic social enterprise emphasizes about the organizational governance, while Islamic social entrepreneurship highlights individual innovation, individual qualification, and also the individual qualities. And the second, from the complementary relationship, despite differences, both share goals of financial sustainability, social justice, and also community empowerment. And the last, about the mutual reinforcement, Islamic social enterprise provides stability and structure, while Islamic social enterprises, sorry, while Islamic social entrepreneurships injects creativity and dynamism. Together, they form a synergetic relationship that strengthens Islamic social business model. And this is the practical application and also the impact of Islamic social enterprise and Islamic social enterprises. We have the example here from the country that have majority Muslim country from Malaysia and Indonesia. Kas Wakaf initiative in Sabah, Malaysia show how religious motives, institutional trust, and social can create sustainable funding mechanism. And from the most best enterprises demonstrate how local assets can be mobilized to empower communities and generate independent revenue stream. And in other hand, in other side, the digital transformation additionally, many young entrepreneurs are using fintech solution and social media platform to enhance accountability and innovation while staying keep the Sharia compliant. So based on this literature review that has been done in this paper, there are some recommendation for the future research direction. First, we will talk about the digital transformation research. After that, hybrid model development and policy framework design. From the digital transformation research, the future research can exploring the fintech and also social media for better innovation and
Yeah.
accountability. And the second, about the hybrid model development can combining organizational stability with entrepreneurial creativity. And for the policy framework, it can be designing ecosystem that support both institutions and individual entrepreneurs. Such effort will not only enrich academic scholarship but also provide practical strategies for policy makers and practitioners. So, in conclusion, Islamic social enterprise and Islamic social entrepreneurship represent powerful, fight-driven approaches to business that go beyond profit, aiming instead for community empowerment, social justice, and also alignment with Islamic ethics. Their growing significance show that Islamic perspective can offer both theoretical clarity and practical solution for sustainable development. So that's all for me. Thank you for your attention today. I go back to the moderator.
Okay, Vayu, nice presentation. About your research, here I would like to ask one question. Based on your review, what research gap is still exist in this domain, do you think?
Sorry, ma'am, could you please to repeat your question, please?
What research gaps are still exist in this domain?
Okay. So the research gap in this about the Islamic social entrepreneur and also social Islamic social enterprise and also social entrepreneurship is about what I explained before about the four main domains that have been for major in this paper. So I will try to share it again.
My question is, what research gaps are not yet solved?
Okay, the research gap is here. So the research gap, we can see that the research is still about discuss about the clarity definition of Islamic social enterprise, the distinction between the social enterprise and the Islamic social entrepreneurship itself, but they did not touch the area such as the digital transformation and also the policy recommendation for the next about the Islamic social business in this field. So the research gap in this research is still about the to follow the development of the transformation digital in social business in especially in the Islamic social enterprise and also in Islamic social entrepreneurship. So for the digital transformation is still lack of research in that area. I think the research gap in that, ma'am.
Okay.
Thank you.
Question from my side.
Yes, I just want to ask one thing that you have suggested the findings. So how this policymakers can utilize these findings to create more supportive institutional system?
Okay, thank you. So from these findings, we have three key research finding here: the conceptual clarity, complementary relationship, and also the mutual reinforcement. So for the institution policy that can make from this research finding, it's for example from the mutual reinforcement from the using the Islamic social enterprise and also with the Islamic social enterprises can contribute dynamism and also innovation, creating the synergistic relationship. So from this kind of new perspective about this business, not just always talk about profit, but we also talk about the social, how to this business can be give the good impact from the social itself. But here, especially using the Sharia compliance, but in the general, actually here, this research can give the perspective that business not just always about profit, but also we have to develop, and we also have to give the good impact for our environment. Then the business cannot just forget that about that specialist thing kan, because that the attention to the social will also increase the business itself, so they can also generate more profit, because their people will see, the society will see that this business not just think about their self, but they also think about ourselves, they also think about the environment. So from this kind of research, we can give the policymakers to have some such as the knowledge to make the regulation about social responsibility, so they don't have just to create the profit, but also pay attention to their environment in the business access, like that, ma'am.
Okay, thank you. Thank you.
Okay, thank you, ma'am. Thank you.
Thank you, Ayu, for your presentation. Now I'd like to invite Jaimin Dave for presenting the paper titled Enhancing Intrusion Detection with Hybrid Deep Learning, CNN, LSTM, and tree-based models with XGBoost and LightGBM.
Yeah, I just send a request.
Yes, you may please proceed with the presentation.
Is it visible?
Yes, it is visible. Please make it full screen and please go ahead.
Okay, very good afternoon, ma'am. My topic is enhancing intrusion detections with the hybrid deep learning and the tree-based model like XGBoost and the LightGBM. It was a part of my research project. I am thankful to my guide Chintan Shah and Dr. Premal Patel for their continuous support. So, this will be the outline for the today's presentation. So, starting from the background to the conclusion, and I am thankful to other researchers who have given me the required number of a research guidance for that I have mentioned in the bibliography. Okay, so ma'am, actually its journey started 4 years back when the entire nation or world was facing a COVID as a pandemic. At that time, the network was also not keep aside, and it were also having challenges. Challenges I have mentions like cyber attack, ransomware, exploitations in the remote access tool, and that's where. So, in a nutshell, the increasing volume and the sophistication of the cyber attack pose a significant challenge to the network security. The traditional IDS often struggle to detect the novel or evolving threats, and that's where we need a adaptive IDS, and that will be the area where I have contributed. So again, for anyone to understand it better, I have just kept a very simple definition of the IDS, which are critical for the monitoring and the protecting the computer network from the malicious activity. There are various kind of IDS which I have mentioned, but I have focused my work for the network-based IDS. So these are the problem statement like which I have come across. Numerous studies have focused on the application of the individual machine learning models. There is a limited research by combining the two model. Probably that may be a machine learning or a deep learning model, and the mainly the importance and the impact of a data pre-processing technique. These were the initial problem statement which I have come across. Now, the one of the infographics which is available on a right hand side, which describe the need for a solution. Why? Because we are having the challenges like a virus, malware attack, or DDoS. So that's where we will be having the data, we will be having a IDS, and the action which will be I have summarized over here: maximizing detections coverage and the reduce the false positive. That's the key idea which I have kept in the mind. Okay, so going further, ma'am, I am having a various literature review. So here in this slide, I will be talking about the traditional IDS, which were rule-based and the signature-based, which had a clear-cut limitations of a detecting the known threats, and it were not able to detect the evolving threats. Here I have talked about the machine learning based model, which is better than the rule based or a signature based model or a traditional IDS. They were able to detect the new threats, but it still does not give a guarantee it is covering the required all the threats. That's where I have come up with the CNN and LSTM hybrid approach. And this hybrid approach has helped me a lot to maximize my coverage for my given data sets. And during the journey, I have also come across the few suggestions from the experts as well as my internal guide. And that's where, ma'am, I have also added the K-mean cluster as well as the autoencoder for my pre-processing purpose. So in a nutshell, starting from the traditional IDS to the CNN LSTM and augmenting with the autoencoder and the K-mean cluster have landed me with my desired proposed model that I will just discuss in a while. So here in one slide, again with the infographics, I am trying to summarize. The study is mainly based on the accuracy, precision, F1 and the recall. So CN and LSTM help me for the spatial and the temporal learning purpose. In a nutshell, my main goal was to increase the accuracy and the maximizing IDS detections coverage. Okay, so the objective to implement and compare the performance of the individual machine learning model, I have added CNN, LSTM, random forest, SVM, many algorithm. I will also discuss that in detail. The hybrid model that integrate and leverage the predictions from the multiple individual model and the effectiveness of the performance during the data pre-processing. Okay, I'm thankful for any researcher may have used it, but okay, TensorFlow, Keras, and the Google Colab, they have helped me a lot in my journey. Now, ma'am, the LU flow datasets, which is available on a Kaggle, which I have used for my research purpose, and that's where I have tried my level best to maximize the detections coverage. So on the left hand side, I have mentioned from year 2020 to 2022 with the Cisco Joy tool as a kit. My researcher have collected those data, and that data I have utilized in my research purpose. So it's a data about a data. So again, just a description about a data. I will prefer to skip it. Okay, so these are the 16 attribute. Slide number this and this. These are the 16 slides where I have worked and where I have spent enough time with this number of attribute and optimize my data. The front view, just one front view of my data sets. It's a very huge data. So just for kept it for the reference purpose, how does my data look like? Ma'am, okay, like this is a slide which I wanted to discuss. I have added the CNN LSTM and also compared. Previously, I have compared CNN LSTM with the standalone CNN, standalone LSTM, and standalone different model. But okay, over the period of a journey, also I got and from the research paper, actually the XGBoost and the Light GBM, which are the tree-based model, which are very good with the tabular data sets. So I the task given to me 100% the standalone CNN, and when I'm combining CNN LSTM together, the CNN LSTM will be having a better performance. So my research was carried out in the different direction by comparing my CNN LSTM performance with the XGBoost and the Light GBM. But the beautiful part, everybody is doing pre-processing, cleaning, dropping, handling the missing value, in a nutshell, removing the noise from your data. But okay, when the auto encoder and the K-mean clusters come in a picture, so instead of only keeping, so far I had only supervised data. So when I added the K-mean cluster and the auto encoder, the unsupervised learning aspect in the research was also accommodated. So Initially, I said I have shown I had a 16 feature in my data set, but okay, by adding a auto encoder, it did the augmentations and I have a more number of attributes, and with the help of a K-mean cluster, I have divided them in a such a way that so unknown attack, I have a 3 classification that I will also show you further. One is the outlier, another is the malicious, and third one is benign. So any flow of a data which is having a not accurate data, that can be figured out by the K-mean cluster implementation. So okay, I discussed about the pre-processing. I discussed about how I have selected CNN LSTM. Now, ma'am, when training and testing the data, in the upcoming slide, I will also show you. I have kept few implementation slide, how I have imported that. Okay, this is a data sets which I have just shown priorly. I have just shown in the Google Colab. The test train model, what I have opted is 80% of my data is a test data, train data, and the 20% is a test data. So entire work which I have carried out over here, that is based on the 80-20 proportion. So again, here I am not discussing the encoding and the decoding part, but okay, this is the one of the diagram which I have come across. So that's where I have mentioned about the auto encoder implementation in one slide. Okay, so I was talking about the 80-20. So again, the test size, which 0.20, which I have mentioned, again, it is just saying that I experimented with the 70-30, 75-25 by keeping just my guidance opinion in mind. And fortunately, I have also received the overwhelming response. So ma'am, for CNN LSTM, Light GBM and the XGBoost, these are the accuracy. Like here I have kept in the floating part, but next slide will be okay. This is the steps which I have finally achieved, and that's how I have carried out my research. So in all parameters, if you can see that my CNN LSTM has outperformed with any model which I have taken into the considerations. Parallelly, ma'am, I have also kept one confusion matrix parameter. So here you can clearly see that for the benign and the outlier category, I am having an amazing result. Ma'am, I am also persistently working hard to make this model better for the malicious node as well. But okay, in a nutshell, that is my journey from starting from the standalone model to the CNN LSTM by accommodating the pre-processing part. So in line with the objective which I had mentioned, what I am concluding with, implemented and compared the CNN LSTM SVM all the model, develop the hybrid model using the CNN LSTM, the various data pre-processing technique been implemented, autoencoder and the K-mean cluster to augment the number of a feature for the data pre-processing. So, okay, that's all from my end. And again, that's an amazing roller coaster journey. Thank you, Kinjal ma'am and Reena madam. Over to you.
Wonderful presentation.
Thank you, ma'am.
In regards to your presentation, here I would like to ask, what challenges did you encounter in balancing accuracy with computational efficiency?
Ma'am, lot of challenges, because when I talked about the Google Colab, the data when I have used a T4 and the T1 as an instance, ma'am, it is taking lot of time. So again, there is always a trade-off between achieving a higher accuracy and having a less computational power utilization. But ma'am, I talked to a lot of researchers. If wanted to have a higher accuracy, the computational power needs more. That is a fact of the life. So again, ma'am, currently I'm implementing everything on this NVIDIA graphics card, which we are having it. And I'm trying to, so far, I have used only free instance, which is available in the Google Colab. It is taking a 45 minutes of a time to train my model. But okay, the more I can train it fast, so that's where now I am relying on the different kinds of a GPU in order to have this trade-off between the high computations and the accuracy, madam.
Nice. Wonderful research. Appreciating work.
Thank you, ma'am. Thank you very much.
Okay, wonderful, Jaimin. I appreciate that you have very confidently presented it. Just one question that I'm having, that all the hidden patterns that you are having or detecting, what is the most effective version that your machine that works, or your, I'll say, collab that works?
Sorry, I just missed some part of it. Can you please reiterate the question?
I'll be just saying that you have collabed two different systems like CNN and LSTM, if I'm not wrong.
Yes,
So,
ma'am.
out of combining these two, on which particular pattern does your machine works effectively?
Okay. Again, what I have understood, I will just try to answer it first. Ma'am, initially I had only combined the only CNN and LSTM. Okay, I have tried and tested my model. It was actually taking a little less time. But when I talked about the pre-processing part, so when the autoencoder thing got introduced in my system, the number of feature which is been added, so that's where the connection, the CNN LSTM, which previously was talking so flawlessly. But okay, after augmenting several features from the autoencoder, it has started consuming a time. So again, whether I have given you answer which you have asked or not.
I'll just ask that you have gone for combining these two systems. So, at which particular area it works more effectively?
Which area, if you talk about those only 4 parameter, which I probably the
Okay.
accuracy. Ma'am, the only one agenda which I had from the beginning, that was the accuracy, and
Okay.
it has given me the better accuracy, ma'am.
Okay, done. Thank you.
Thank you very much, ma'am. Thank you.
Yeah.
Dear presenter, for your wonderful presentation. Now I'd like to invite the next presenter. Next we have Hasin Mahir, and he's going to present the paper title On-Device Tree-Based IAQ Forecasting on ESP32, a Comparative Evolution. Hasin, you may
Yes, sir.
please
Thank
proceed
you.
with the presentation.
Yes, 1 minute. I'll just start up the presentation. I'm sharing my screen. Just a second. Sorry for the delay. My computer asking me to restart Zoom. Is that okay?
Yeah, I think so. It will take some time, right? So we'll
Yeah.
consider next one till then.
Okay. Thank you. Sorry for the inconvenience.
Okay, not an issue. So next we have Amog, and he's going to present the paper title. Just a second. Yes. He's going to present the paper title Quantum Enhanced Hybrid Intelligence Fuzzy Logic Meets Neural Networks in Data-Driven Systems. Amog, you may
Yes, sir.
please proceed with the presentation.
Yes, sir. Thank you so much. Am I audible?
Yes, you are.
Yeah. I'll be sharing my screen.
Sure.
Please let me know if you can see my screen.
Not yet.
Okay. Now?
Yes, now it is visible. Please go
Yes.
ahead.
Yes. Hello all. My name is Amog. I currently work in Bosch in an R&D department. Today I'll be presenting my paper on quantum enhanced hybrid intelligence, where fuzzy logic meets neural networks in data-driven systems. So firstly will be this is my agenda for today, by introducing the hybrid intelligence that is being developed by us along with the core technologies. Then we'll be explaining the method that we have followed to get the solution and how the quantum computing has been integrated, and also I'll be explaining on the applications and the future directions. Now, firstly, I'll be giving you an overview of how the hybrid intelligence is being made. Uh, then, so first we'll understand what is the advantage of the fuzzy logic. The main thing why fuzzy logic was taken by us is because it helps us in managing and understanding the uncertainty and imprecision, and also helps us in giving a better decision making support system. If we go to neural networks helps us in recognizing the patterns. It might be in terms of large data sets and also in terms of complex data. Why quantum computing? Quantum computing has two main technologies that is being two main concepts that is being implemented. One is the qubits and the other one is the entanglement. Qubit, as you can see here in this diagram, this is a representation of the qubit. As we know, in classical bits, it's either 1 or 0, but in qubits it can be in both the states. So this is how the qubit is being represented. This is the qubit, as you can see, and then it can be either in 0 or in 1. It depends on the energy that is being given to that qubit. And the entanglement will help, and the entanglement for these qubits will help us providing parallel computing much faster. And the hybrid intelligence, by with the combination of fuzzy logic, neural network, and quantum computing, will help us gaining adaptive learning, and also the complex reasoning ability is being increased. Now I'll be going to the core technologies. As we mentioned about the fuzzy logic, here we'll be getting the uncertainty with using of degrees of truth, and the neural network will help us in
Sorry,
getting
Among,
and
but your
identifying.
slides are not moving.
Okay, just a minute. You think you can hear me, right?
Yes, I can hear you, but your slides were not moved that time.
Okay. Yeah. Now can you see the screen?
Your video is audible, not screen.
Okay. Now is it visible?
Yes, it is visible.
Yes. So using the fuzzy logic, we are getting the uncertainty with the degrees of truth. For the neural networks, it's from identifying the complex patterns in the data set, and it helps in learning the complex patterns. The combination of this will enhance the adaptability of any of the machine learning or the AI models, and also by introducing quantum computing, it helps us in increasing the performance of the models and also the scalability part. Now combining this, it helps us combining all these three paradigms, we get a hybrid intelligence system where we can handle complex and uncertain data much faster, much easier, and much data efficient methods can be implemented. Now moving on to the integration of quantum computing, as you can see, there is a flow that have been mentioned here. Data encoding, then it goes to quantum feature extraction, quantum model training, and then at the final stage it will be prediction. Any of the data which we take a machine learning model or an AI model, first the data will be encoded. After encoding, using the quantum feature extraction, the feature extraction will be segregated, either it might be in the classification method or it might be in terms of domain, or we group them together, anything. So in quantum methods we'll be extracting the features, and again the quantum model training, here we'll be using the uh, quantum gates and the qubits along with entanglement to do the model training for better accuracy and better performance. And then at the final stage, it will be reverted back to the original classical bits so that we can get the prediction right. So now, if we can say the quantum bits or the qubits, it helps us in giving the superposition of the state that is being made, and also this entanglement, as discussed, will enable us in parallel computing in much faster way. And if quantum computing is integrated with machine learning, we can improve the data security in that system and also the decision making predictions that is being made. If it is then I'll go to the next slide, and this is the example of the results that we have showcased by using our hybrid intelligence. As you can see, the original model, which consists of the fuzzy logic and also the neural network model. As you can see here, the 32 GB and 64 GB are the RAM sizes that we are using in the system, and the VM is specifically given as the virtual machine. So if I'll just take the first example, original model, which is run on a 32 GB machine, which a data set size of 10,000 phrases in a data set as a CSV. The model training, the time is taken in 31 seconds, and now the accuracy found out is 44%. This is the regular neural network model along with the fuzzy logic. And as you can see, if it go for 64 GB, we can also increase the data set to the 50,000, but and the rest, we can see it's a kernel crash or there's a memory error, and the accuracy is remaining the same. But you can observe here, EHC is there are three gates that we have used in the uh, in this method, where that is the entanglement, Hadamard, and the CNOT. Using these three gates, along with that model, integrating that to the model along with the same size, the same 10,000 data set, the model training is done in 3.6 seconds, and the accuracy has been increased to 93%. And as you can see here, any of these bottom three categories, none of there is a kernel crash or memory error. So even though I would like to say we introduce the complexity of this quantum computing in our classical systems, yet there is no complexity obtained for the kernels to work or there to memory error. So we can see that there is an increase in the accuracy and also decrease in time and increase in performance. Sorry for that. And as we can see here, if we are going to the fuzzification, how we are doing is it input data, as we can see the classification, then it goes to integration of
Sorry to interrupt you, but you have last 1 minute for the presentation.
okay, so the future, I'll go to the applications where this hybrid intelligence will work. It works in the it works in mainly our real-time traffic detection, and also in medical diagnostics, where it might be medicine development or also a production of medicine based on the disease. Either ways it can be made, and I have one patent under this domain also regarding the quantum computing. And regarding these two topics, I still have other two patents in my company. So, and there are two other research papers again with the same similar domain. So the future trends, if I have to say, if there is a very good hardware advance and it is being very well integrated with the AI model, by giving you an example, as of now, there's a supercomputer that is there with Meta, which can process 10 electrons in certain period of time. And if the same system has to process 20 or 30 electrons, it gets complex and it takes about 1 billion years to compute that 20 electrons. But integrating quantum computing hardware with that AI, with that supercomputer, that can be done within minutes. So this is how quantum computing has been used, and there are a lot more to go. Because of the time constraint, I'm a bit moving ahead fast. So thank you all. I would like to take up the questions now.
Just
Yes, ma'am.
one question that I'm having is how scalable are the systems and what limitations have you thought that it can have when you talk about quantum computing resources?
Yes, so as far as we know, there is no exact quantum hardware that is present in the world, and even the hardware is being still under development. As you can see that I have told you that I have using these gates as such to do it, but everywhere in the world there is simulation that is going on, but according in my research and based on the patents, I cannot reveal on what I have done it, but it has been promising results that I have done it in the classical system and it is working. So based on that, we can do the scalability if we have enough GPU computational power. It might be in terms of laptop or it might be in the virtual machine in Azure as well. So it is scalable in terms of that, and I can promise you, if then no regular AI model takes 1 hour to train, integration of this hybrid intelligence will be trained in 1 minute. So in embedded system domain, or it might be in automotive domain, that's where my company is working on, and we are also working on in the similar part of it. It will help them. Their training their training for that embedded software, just by deploying it into their embedded system, it's taking for them 4 to 5 hours. So this 4 to 5 hours can be reduced to 1 hour or even half an hour, depending on their architecture which they use. So this is how it is flexible, and I would love to share you the results and the methodologies that we shared, but since it's in a patent processing, we are not able to reveal everything.
Okay, all the best for your project and hope to
Thank you so
see
much.
you in on the news or in the news soon, if I'm not wrong.
Thank you so much,
Great,
ma'am.
great. Thank you.
Okay, can I ask one question, Amokji?
Yes, ma'am. Yes.
How do you address the challenge of hardware limitation in implementing quantum-based approaches?
Yes, so as far as I said the same thing to Kinjal ma'am, there is no specific quantum hardware that is being developed yet in this world, and because of that constraint, we had a flow where we can implement it on a quantum computer, but because of the development issues and also the error correction and all those stuff, we were not able to take up that flow since, and we have take up this flow where it can be implemented on the classical system. So since I mean, as I said earlier, there are resources to implement this system here in the current situation, but not on the quantum hardware. And also because of my patenting, I cannot reveal all the mathematics that has been involved there. So that is the thing.
Okay, okay, no problem at all. Best
Yeah.
wishes, sir.
Thank you so much. Yeah.
Yeah.
Thank you, Amok, for your wonderful presentation.
Thank you, sir.
Yes, now I'd like to invite again Hashin Mahir for
Yes, sir.
presenting the
I'll start
paper on
sharing
device
my screen.
creation. Yes, Hashin, you may please proceed with the presentation.
Yes. Is my screen visible?
Yes, it is
Yes, sir.
visible.
Okay. Good morning, everyone. I'm Hassan Mahir, and today I'll be presenting our work on on-device forecasting of indoor air quality, implementing on the ultra-low-cost ESP32 microcontroller. This project is in collaboration with the Department of Computer Science and FabLab IUB at Independent University, Bangladesh. Our main question was, can we perform reliable week-ahead IQ forecasting directly on a $6 microcontroller without relying on cloud solutions? And in this talk, I'll show you that we have answered that and solved this issue. So indoor air quality, or IQ, it's not just about comfort or luxury, it's about health and productivity. If we look at CO2 buildup, any CO2 buildup above 1,000 parts per million people experience fatigue, headaches, and reduce cognitive performance. For classrooms and offices, this can directly impact their learning and working efficiency. And in private universities, at least in Bangladesh, almost all classrooms are completely enclosed, whether they are air conditioned or not. So CO2 buildup is a major issue, which we will see in a later chart shown on the presentation. PM 2.5 is particulate matter that are in size 2.5 microns, and they serve as a good measure for larger and smaller particles since they are the most common size of dust in the air that is not visible to the naked eye. Long-term exposure is linked with respiratory diseases, cardiovascular problems, and impaired lung development in children. Now, the problem is that these pollutants accumulate gradually in enclosed spaces, as I've mentioned. By the time you measure these air quality measures, it's already too late and the harm has been done. So the key idea is to be able to forecast what's going to happen soon in the future. Now, the problem, which I touched on briefly, is that in the conventional approach, the microcontrollers, they only take the sensor readings and submit them to the cloud. And then they use their own private servers or cloud solution like AWS, Azure, to do the calculations and run the machine learning models, which can be expensive if the environment or the institution is resource constrained and on a tight budget. Our goal here is to show that it is feasible to do these calculations on edge-based devices like the ultra-cheap microcontrollers with very usable accuracies. Now, our contributions, we have shown a comparative evaluation where we have compared three popular tree-based ensemble methods. Those are random forest, XGBoost, and LightGBM, and we have applied them to our indoor air quality data from the classroom. For the edge deployment, we have used an ESP32 S3 microcontroller, which has 16 megabytes of flash memory, 8 megabytes of PSRAM, and despite such limited resources, we forecast both carbon dioxide and PM 2.5 levels for up to 1 week from the data we have trained it on. That's what we've tested on. It's a work in progress. We're going to have more publications soon. We have developed a complete tool chain. We have developed a complete pipeline for feature engineering, offline model training on just regular consumer hardware in minutes, and also automated the process to convert this model into a raw C code for the microcontroller to be able to run. We have also systematically evaluated both prediction accuracies that we've mainly focused on, which are mean average precision error and root mean square percentage error. And we have looked at the device efficiency in terms of how long it takes for the microcontroller to compute per step and the entire week. This way, we not only show that forecasting is possible on these devices, but we also provide a reproducible framework, which we will be soon publishing on GitHub. If we look at the system architecture, I've already mentioned the hardware. We are taking our sensor readings at 10-second intervals actually, and then in the microcontroller for the prediction, we are combining those into 30-minute intervals because the instantaneous data is quite noisy and it's not suited for machine learning. A lot of cleaning has to take place, which if you look at the flowchart, it's also done inside the microcontroller itself. The microcontroller also parses all the features, the lag values, the cyclical time encodings. We have days as a cycle as sine wave and also week as a sine and cosine wave. We also have rolling averages and also lag values from the same time last week since it's a classroom and they follow the same schedule in a given semester. And we have used these pre-trained models we have trained on our computers and generated the feature vector and then shown the predictions on a web dashboard also hosted on the microcontroller itself, which is why we have chosen a low-cost microcontroller, but one with 16 megabytes of flash so that it can hold the HTML files. In terms of the machine learning models, we're using the three tree ensemble models, random forests. It uses bagging of independent trees. It's robust and stable, but it requires evaluating all trees at every step, making it slower and heavier. It does require a lot more trees, a lot more depth compared to LightGBM and XGBoost for the same performance, and it's not our best performer. XGBoost is a gradient boosting build tree, and it corrects the errors of the last, and that's how it builds the tree. It's generally more accurate, but it has a higher computational cost if the depth and number of trees is the same, which it's actually much lower than our random forest implementation. And finally, we have Light GBM, which also uses boosting like XGBoost, but it has optimizations like histogram-based splits and leaf-wise growth. It's designed to be fast and memory efficient, which is critical for embedded devices like this. All models use the same feature set, trained offline, and were converted to C for deployment. This way, differences in performance are purely due to model architecture and not pre-processing. If we look at the quantitative accuracy, and I would like to have the attention to the chart first. As we can see, there are very distinct peaks on the graph. These directly correlate with the occupancy of the room. So Light GBM has demonstrated superior forecasting accuracy, consistently outperforming the other models with the lowest errors and root mean square error for both carbon dioxide and PM2.5. The latency is also quite low because of the small tree, and it's also hence the fastest one for specifically carbon dioxide. Here's our feature importance for both carbon dioxide and PM2.5. For carbon dioxide, as expected, the is class variable, which shows whether a class is in progress, it directly correlates with the occupancy. So whenever the occupancy is high, we have the highest carbon dioxide. And the one of the most important features for the carbon dioxide prediction is the carbon dioxide lag 336. Sorry for the technical term. That's basically 336 steps into the past, which is exactly the same time last week. So exactly the same time last week, which shows us what the situation is like in that class specifically, since each class has different number of people. That is also one of the key accuracy drivers in this model. For PM2.5, we can see that the time index, which is basically just a continuous time index from the start to the finish of the data set, it shows a very high importance, showing that particulate matter has been growing in Dhaka city for
Sorry to
a very
interrupt you,
long
dear
time now.
author, but you have last 1 minute for presentation.
Oh, sorry, I'll make it quick. So here's the inference time. We can see that the slowest model, in fact, also takes just 1 second, even on such a small microcontroller. So clearly this is feasible, and we can run the prediction multiple times a week with the latest data. In conclusion, we have successfully demonstrated that advanced tree-based models can be efficiently deployed on tiny devices like the ESP32S3 with some small performance hits to perform multi-day indoor air quality forecasting, provided that the environment is stable, such as a classroom, which is enclosed. And these boosted ensemble trees, they delivered higher accuracy than random forest while maintaining strict memory constraints, as they're smaller than random forest. The impact is that this enables the adoption of such low-cost $6 microcontroller-based systems as standalone machine learning predictors. Our edge-based approach improves reliability and privacy, eliminating the need for cloud connectivity since we do not have to show the occupancy to our cloud providers. For future work, we will be looking at model optimization techniques such as quantizations instead of using floating points to further reduce inference times so that maybe we could use it on even lower cost hardware so that even rural people can afford it in their schools. We also enable incremental on-device learning capabilities in our future works to allow the system to adapt slowly over time. We would like to acknowledge FabLab IAB and the Department of Computer Science for their continuous technical support throughout the development of this work. This research was partially supported by the Department of Computer Science through internal funding. Thank you. Any questions?
Yes, Haseen, I would like to ask one question. Do you see that whichever solution you have suggested here in your research is scalable for large scale smart city automation?
That is actually an interesting question. And the answer is not that simple because it depends. For example, if we look at strictly outdoor air quality, our solution, it will not really stand up because as you saw, the same value from last week was a very key indicator. in our performance driving, in our feature importance. And that is definitely not going to be the case in outdoor. However, if we look at offices and schools, especially places that are air conditioned and airtight, this will definitely be a very good key indicator because they follow the same daily and weekly schedules. And since the cost of the device is very low, I think that this is just going to be a trivial thing that you just install and forget until you see an alert.
Okay.
Uh,
Thank you.
yes. In continuation to this, I just want to ask that how scalable your approach when you go for varying IAQ conditions? Let's say, for example, there is a large room or multiple rooms, multiple classrooms where you are having different IAQ conditions. So how scalable this approach will be there?
From what I've seen as of this current iteration of our project, all we had to do, we actually tried it in 3 different classrooms on 3 different floors. They have the similar size of room and similar occupancy. What we only had to do was we had to just retrain using data from that room, and that was it. We had similar accuracy and training time. It actually took only like 2.5 minutes on my modest computer with a 6-core processor. Thank you.
Done. Thank you.
Okay, thank you, Hussein, for your wonderful presentation. Now, I'd like to invite next presenter. Next, we have Sudarshan Sharma, and he's going to present the paper Simulation and Analysis of DDoS Attack using ML on MA Maveling Protocol in UAV communication.
Good afternoon, sir.
Sudarshan, you may please proceed.
I'm going to present this piece. My screen is visible.
Yes, it is visible. Please make it full screen and go ahead.
Good afternoon, respected chair professors and my fellow researchers. My name is Sudarshan Sharma. I am a student of Punjab University, Chandigarh, and my co-author is Ms. Nita Chopani. And I have completed this research under the guidance of Dr. Sakshi Kaushal. Our work mainly focusing on the and UAV devices against the cyber attacks, particularly in particular attack DDoS in machine learning. Then I'm just taking you to our research by step by step. Let's move to the introduction session. Unmanned aerial vehicles widely deployed in agriculture, defense, and in surveillance also because of its lightweight and versatility. And as we know that UAVs are not require any UAVs are not require so much of encryption and other security. They are not coming with inbuilt security features because of the Maveling protocol, which is a very lightweight protocol and used for communication between the ground control station and the UAV device. And basically, the devices are mainly spoofable because of the lack of encryption and 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 some internal features, those are not included in Maveling protocol. There is some vulnerabilities like injection attacks and spoofing, eavesdropping of data is also possible. Then just now, we are moving to the goals of our research. The first goal of our research is we have using the simulated environment for completion of this research. We have using the software Mission Planner, which is the simulator, which works as a simulator, where we can input any command and it directly reflects like the real world environment in this simulated environment. And the next one is we are going to face so many difficulties while searching for a data set on the Kaggle platform. I am facing so much of difficulty because publicly data sets are not available. Then after that, I am going to collect my own data set with the help after performing a DDoS attack on the in the simulated environment, and after that I have been used machine learning model for the classification between the normal packets and the normal packet and the spoofed packet. The key findings after applying the machine learning model, we have applied three machine learning models. The first one is support vector machine, and the second is the random forest model, and the third is k nearest neighbor. Out of the KNN model have shown the very high accuracy. Training and testing both accuracy levels are very high in KNN. And we are just moving to the literature survey section. So, sorry, protocol. Next, we are going through with the mapping protocol. What is actually the mapping protocol? As we have, I tell you, mapping is a very lightweight protocol used for communication between UAV and ground control devices. Here is the diagram shows the frame, mapping 1 and mapping 2 frame structure. Mapping 1 frame structure comes with 8 to 63 bytes, but mapping 2 protocol having some extra blocks added. The very first block is INC flag and CMP flag. The working of these flags, they can compatible if the, for example, if the packet is not compatible according to the heartbeat, then labeling protocol discard this packet. These INC flag and CMP flags works like this. And the different fields are also indicated with sky blue color. And the next section is next block that is very different with the mapping 1 frame structure is the signature block. It basically ensures that link is tamper proof or not. For example, if any device, UAV device is flying on the sky, then signature 13-bit bytes has ensured that the packet and link is spoofable or not. So I hope this frame structure is clear. When next we are moving to the literature survey section, we have going through with all the most of so much of papers, but mainly we have seen that DDoS attacks mainly focus within only in these two papers, and there are research gaps also that I have found during my research. The first one is SITL based security studies. There is very much lack of security studies because no one talks about security till now. We are just trying to deploy the devices in real world and do not talk about their security. UAV is a very nice industry, as we know that, and research expert, according to the while doing this research in this section, I have found that before 2030, we have deployed more than 30 million devices for the real world application in the real world scenario. And the second difficulty I have faced during the research, publicly not are available.
Sorry to interrupt you, Sudarshan, but you have last 1 minute for the presentation.
Okay. So can I move a little faster?
Yes.
Then proposed work, I'm just talking about proposed work. But we are going to do first, we just need any simulator environment. For the simulator environment, I just need a mission planner software, and I am going to perform, I am going to write customized Python scripts for the performing DDoS attack in a simulator environment. And after the attack pattern, identifying the attack pattern, we are going to capture the data by the using tool Wireshark. And after that, we are going to use machine learning models, ISBM, RFM, random forest, and k nearest neighbor for the classification the packets between normal packets and the attack spoof packets. And after that, we will evaluate that which model works good in all of the models. And in the next section, we are training our model with according to these feature transport layer, which protocol is used, UDP and TCP. and the next one is source IP, destination IP. This is the basic overview of my data set that.
Excuse me, sir. Sorry to interrupt you. Can you please go to the conclusion slide, please?
Thank you. Yes.
Yeah.
In the conclusion section, the
Mhm.
Mapling protocol is vulnerable to UDP and TCP floods because when we have deployed large-scale DDoS attack, then UAVs are completely destroyed. Then the next one is we can easily disrupt the communication between UAV and CCS communication. If I'm going to match that particular frequency and the satellite, I'm going to destroy that particular UAV device. Deployment of UAV dataset development. This is a very serious problem. The DDoS attacks and the UAV security datasets are not publicly available, and out of this, KNN model is the best model that I found during my search. It can give me the very high accuracy within 25 seconds, 99.8% accuracy it can generate while when I'm going to train this model.
Okay, so here I would like to ask a question. Can your approach be adopted for other communication protocols beyond this MAV link? What are the protocols?
There is more protocols. There is more protocols like UAV scan, and there is one more protocol has come, but they are also comes with a less encryption. UAV is a device. You are not going to use the heavy encryption, but we have to find a way we can use the encryption algorithms and authentication. No any unauthorized device entered in our network and destroyed the whole communication. Data spoofing is also very much easy in UAV devices. That's why I have performed a DDoS attack.
Okay, over to Kinjal, ma'am.
Yes, ma'am. I just want to ask one question that goes like, what practical measures do you recommend in enhancing this UAV security?
When we are using the security hashing algorithm, just like just in WhatsApp, SHA-256 algorithm has been used for security hashing. We can use that algorithm in UAV communication also because this is a very lightweight algorithm and we can easily deploy that in particular that is used for UAV communication.
Oh, okay, done. Thank you.
Thank you, sir.
Thank you so much. Thank you so much, ma'am.
Yeah.
Yes, ma'am.
Yeah.
Thank you, Sudarshan, for your presentation. Now I'd like to invite the next presenter. Next, we have Shushrutan Babu, and he's going to present the paper titled Transforming Capital Markets Through Blockchain Technology, Research Trends, Challenges, and Regulatory Insights. Dear presenter, you may please proceed with your presentation.
So am I audible?
Yes, sir, you are audible. Please proceed.
Good morning, everyone. I'm Shushrutan Babu. I'm delighted to present this work that I co-authored with Suparna Ray and Niranjan Babu, titled Transforming Capital Markets Through Blockchain Technology, Research Trends, Challenges, and Regulatory Insights. This study explores blockchain as a paradigm-shifting force in financial market infrastructure with a particular focus on India. This is the Index Abstract Introduction Literature Review, Research Gaps, Proposed Methodology, Results, Comparative Analysis, and Conclusion. This research, jointly conducted with my co-authors, adopted a mixed method approach combining bibliometric analysis with case studies. We found that blockchain can improve efficiency, transparency, and decentralization while also reducing settlement costs. However, the adoption remains limited due to the regulatory ambiguity, scalability constraints, and legal uncertainties as it must be implemented by the governments in India like SEBI, in US, SEC, they must implement the blockchain in capital markets as it cannot be done individually. And our contribution lies in comparing global regulatory approaches, situating India's caution adoption within the landscape. Here, capital markets are often described as a nervous system of the economy, mobilizing capital, providing liquidity, but traditional systems suffer settlement delays, mostly like 1 or 2 delays of settlement of payments, and counterparty risk and excessive reliance on intermediaries. Blockchain technology offers T+0 settlement cycle as an immediate payment cycle, as an immediate settlement for payments, and immutable audit trials and fraud reduction. Together with my co-authors, our motivation was to examine research patterns, regulatory developments, and system barriers to blockchain adoption. Here's the literature review. Earlier research has questioned blockchain as a general purpose with the research applications of cryptocurrency and blockchain technology, which can be used in capital markets. And there's a research gap, huge research gap of implementation of blockchain in capital markets. And here is a research gap. Our collective review identified critical gaps here. A shortage of longitudinal empirical studies, limited cross-country comparison, insufficient attention integration with legacy systems. As governments are not ready to implement blockchain currently, as they are working with the legacy systems, weak coverage on regulatory coverage and investor protection. On our proposed method, we designed a 3-step framework. First, we established the research problem and reviewed the existing scholarship. Secondly, we employed a mixed methods design, bibliometric analysis of global publications, coupled with case studies of India and international markets. Thirdly, we conducted a comparative synthesis, enabling us to draw insights from both theory and practice. And here are our results. Our bibliometric analysis shows a sharp increase in blockchain research after 2016, with the US, Europe, and China leading. India is emerging, and there are only 4 to 5 papers of blockchain in capital markets in India, but India is still in an exploratory phase. The case studies reveal that SEBI has some initiatives. They are doing some initiatives and sandbox initiatives and RBI experimental programs of implementation of blockchain. And they are recently in 2022, they announced the digital coin, which was a result of implementing blockchain. And in EU, MiCA framework, comprehensive digital asset, they have working. EU has been working on a framework that can implement blockchain. And in US, SE tokenization has been done, and they have been working on implementing blockchain in their respective countries. And our comparative analysis, India's approach is prudent and sandbox based. They are testing blockchain in capital market. They are not implementing it right now, while the US has been slightly implementing with their technology based things, and they are not fully implementing blockchain in capital markets. In conclusion, blockchain as a technology is a disruptive technology, and it can be easily implemented. It can improve efficiency and transparency, but faces barriers from government and implementation from the governments all over the world. There is a cross-jurisdictional regulatory problems which needs to be studied and it needs to be worked out. And the pilot projects, they need to initiate certain pilot projects to implement blockchain. And our research builds an interdisciplinary foundation drawing from finance, law, and technology literature to provide both conceptual and empirical grounding. And there are papers which are coming up which are worked with, which are blockchain. It is hard to implement without the government support in this thing. Thank you for attending.
Okay, so, okay. Yeah, thank you for the presentation. So, in your opinion, what will be the biggest regulatory hurdle in implementing this blockchain, particularly in field of capital market? What
Ma'am,
is your opinion on this?
in this case, it's all about the governments, ma'am. Governments implementing it.
Yes, but what is the biggest hurdle, do you think?
Biggest hurdle.
It is all about maintaining security, you know.
Yes, ma'am. It's about maintaining security and transparency. Blockchain
Yes.
offers extra layer of trackability in this case, but the implementation more be technological barriers, ma'am, in this case. Implementing the technology. Yeah.
Okay. Okay. Over to Kinjal, ma'am.
Yes. So, what are the main challenges that stop this large-scale adoption of blockchain in India?
The main challenge is blockchain has not been implemented throughout the world. It's in a test phase in capital markets, ma'am. They are working on it as a pilot project, as sandbox test cases in India. In 2022, the government also introduced digital rupee. They are working on it as it will take certain time, ma'am.
Okay. Thank you. All the best.
Thank you, ma'am.
Thank you, dear presenter, for your presentation. Now, I think so we have completed all the presentation in this session.
Yes, sir.
Right. Okay, so I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough to all the participants. We, on behalf of whole team, thank you for your support during this fourth version and all the previous three versions of the conference. We will be happy to have you in fifth version in 2026. All the presenter would be getting their digital certificates through email within 2 to 3 working days. Further, the publication will be live within 7 to 8 months, so kindly cooperate with the team ISBM 2025 and Global Knowledge Research Foundation. Further, I also thank our session chair for being for chairing the session. Ma'am, there is a one token of appreciation to be a chair on behalf of Global Knowledge Research Foundation and team ISBM 2025. This is for Kinjal ma'am, and this is for Rima ma'am.
Thank you. Thank you.
Thank you very much.
Thank you.
Yes. Thank you, ma'am. Thank you for your valuable presence.
Thank you.
Thank you
Okay,
for
so-
being such a part of this wonderful conference.
Definitely.
Thank you very much for inviting us and giving this opportunity to have coverage with this wide audience here.
Definitely.
So thank you very much.
Thank you, ma'am. Thank you.
Thank you. So each one of you have contributed something into the field of, I'll say, knowledge that we already had. And that is a remark that I'll go for that. Thank you so much for being such a wonderful, I'll say, presenters, scholars, and teachers. Thank you. Thank you so much.
Thank you, ma'am. Thank you. So now I request all the participants that you may all please turn on your camera so we can capture the good memories of this virtual conference. I request everyone, if it is possible, you may please turn on your camera. Yes. Thank you. Thank you, everyone, once again. Thank you, ma'am.
Thank you very much. Yeah.
Thank you, sir.
So shall I leave the meeting, sir?